definition of air pollution is the contamination of the atmosphere by harmful substances such as gases, particles, or biological molecules that can adversely affect human health, living organisms, and the environment. These pollutants may come from the natural source like volcanic eruption and wildfire, or from human activities such as vehicle emission, industrial process, and burning of fossil fuels. Common air pollutants include carbon monoxide, nitrogen oxide, sulfur dioxide, particulate matters, ozone, and volatile organic compounds, all of which contribute to environmental damage and health problems.
Moving on to source and formation mechanism. There are two key pollutants related to air quality. Let's start with outdoor sources. Vehicle exhaust is a major contributor, releasing particle matter 2.5 due to the fine particle release during fuel combustion. The higher the number of particle matter, the more harmful it is for the body. Next, construction activities and road dust mainly release PM10, which are larger particles. And then open burning also contributes to both PM2.5 and PM10 levels. When it comes to indoor sources, PM2.5 levels are significantly higher during cleaning activities. This is mainly due to the suspension of the dust. Another factor is poor ventilation, which allows outdoor particles to stay trapped indoors and accumulate over time. Now let's look at the formation mechanism, where we have two types, primary PM and secondary PM. For primary PM, it is released directly into the air from sources like combustion. For example, during incomplete combustion of fuel with the reaction below, where PM refers to soot or ash. For secondary PM, it is formed through chemical reaction in the atmosphere. For instance, the main sources of sulfate particle is through fossil fuel combustion, and the main sources for nitrate particles is due to emissions, agriculture, or maybe even traffic.
And now I will briefly explain the effect of air pollution on our health, environment, and the climate change. For effect on our health, when we breathe polluted air, harmful gases and tiny particles go into our lungs. This can cause asthma, lung disease, heart problem, and even cancer. Children and older people are most at risk. For effect on environment, air pollution causes acid rain, which damages soil, water, and plants. It also produces ozone near the ground that harms crops and forests. Another problem is eutrophication, where too many nutrients leads to algae overgrowth in rivers and lakes. For lastly, effect on climate change. Some air pollutants like carbon dioxide and methane trap heat in our atmosphere. This leads to global warming, causing melting ice, rising seawater, and extreme weather like fall and heat wave.
So, let's move on to regulation or guideline in air pollution, which is first global standards and the second one is monitoring and enforcement. So next, let's start with the global standards, which is divided by two. First, WHO air quality guidelines, and the second one is IPCC recommendation. So let's start with the global standard that guide air quality management around the world. So the World Health Organization, or as known as WHO, has established a quality guidelines that define safe limits for key pollutants like PM2.5, PM10, nitrogen dioxide, sulfur dioxide, carbon monoxide, and ozone. These guidelines were updated in 2021 to reflect new scientific evidence showing that even low levels of air pollution can pose significant health risks. Another key body is the Intergovernmental Panel on Climate Change, or IPCC. While it's known for climate research, the IPCC also emphasized the need for integrated policies that tackle both air pollution and climate change together. They advocate for sustainable practice and a shift towards cleaner energy systems, which can improve air quality and reduce greenhouse gas emission at the same time. Next, enforcement of this regulation depends heavily on monitoring. One widely used tool is the Air Quality Index, or AQI. This index translates complex pollution data into a simple number and color scale based on pollutants like PM2.5, PM10, ozone, and nitrogen dioxide. it helps the public understand how clean or polluted the air is on any given day. Air quality is tracked using a combination of ground-based station and satellite systems. This dual approach provides real-time data and helps identify trends and pollution hotspots over large regions. Together, regulation, monitoring, and public awareness form the backbone of effective air quality management. To sum up, global guidelines, national laws, and modern monitoring systems work together to protect public health and the environment.
Case study: Air Quality and Health Index in Road City. Background: Road City, located in the eastern Mediterranean, face a pollution challenge from traffic, port activity, and urban density. Researchers monitor air quality across three zones: the port, urban center, and a high traffic area. Challenge: Pollutants like particulate matter 2.5, nitrogen dioxide, and ozone were measured to assess health risks. The city's layout and weather patterns, especially wind, influence how pollutants spread. The goal was to understand how different areas affect public health. Action taken: Install mobile air quality monitoring system (AQMS) in all three zones. Collected hourly data over 10 days in November 2022. Calculated the Air Quality Health Index (AQHI) to evaluate health risks. Analyze meteorological data, wind speed, temperature, boundary layer, height using ERA5 ray analysis. Result: Highest pollution levels were found in the city center. AQHI range from low to moderate, indicating some health risks. No exceedances of EU pollutant limits, but climate conditions play a major role in pollutant dispersion. Wind patterns help reduce concentration in some areas, but also transported pollutant across zones. The reflection of the case study is the highlight the need for localized air quality strategies, such as integrating urban planning with pollution control, support the case for green development in coastal cities, and encourage further use of AQHI for public health communication.
In conclusion, air pollution threatens both health and the environment. Major pollutants like particulate matter and nitrogen oxide come from vehicle industry and natural sources, causing respiratory disease and the climate impact. Key solutions include enforcing air quality standards, adopting clean technologies, and improving urban planning. Public awareness and collective action are essential for progress. Through coordinated effort, we can achieve cleaner air and the healthiest future.